Welcome to the session on IEC Type 2 Release 5 on provisioning and managing a lightweight multi-access edge cloud on AWS. I'm Vinodini Raju. I'm the founder CEO at GoPaddle. I'll be introducing you to this blueprint and then do a demo after that. Before we start with the presentation, I would like to introduce you to Acreno and IEC. Acreno is a mature project from LF Edge, and IEC stands for Integrated Edge Cloud, which is a blueprint from Acreno, which aims at building integrated edge infrastructure. MEC, as the name stands, it offers cloud computing at the edge of the network, closer to the end user. So end users get the scalability and flexibility of cloud, along with ultra low latency and the real time experience. So for building any application that runs on these edge environments, the requirements for developer environments is also very similar. So developers should have the capability to test the latency and the localization aspects of those applications. So in this blueprint, our goal is to give a real-time development environment which is closer to the edge, or it runs on the edge. So developers can test their applications in real time. And while we do that, we want to make it much more developer friendly. So we bring in a couple of out of the box DevOps tooling and integration, like AI ML platforms and tools, so that developers can build intelligent applications. Some of the data processing frameworks like EdgeX Foundries to collate data and synthesize the data from different IoT devices. So while we do that, it doesn't stop with providing a developer sandbox. They should be able to extend that to production environments. So we also look at the technologies that can enable us to scale these environments and offer high availability. We are looking at a collaborative development model across service providers and third-party developers. So we need to bring in some of the unified developer experience and governance, like the auditing and the access controls across developers. And we're also leveraging AWS, so it brings down the cost of capital and operational expenses of setting up such an edge cloud. While we do that, our focus has been on making the developer experience very seamless. So we are looking at providing a low code or a no code experience which can accelerate innovation and delivery. So we evaluated a couple of technology stacks, and MicroCreators seem to be a good fit. So MicroCreators is a lightweight Kubernetes distribution from Canonical, and we can spin up this environment in just a single command in under a single minute. So we can make use of the Snap installer, which itself is very lightweight. So developers can actually start with a single node instance of MicroCreators, and they can extend this for 3+ nodes. The moment we add more nodes, we can also enable high availability mode. One of the other good aspects of MicroCreators is that we get some of the out-of-the-box tool chains, like the Kubeflow, Prometheus, and image registry. So we can spin up a completely a self-contained Kubernetes environment for developers. Coming to AWS Wavelength, it's one of the services introduced by AWS that brings cloud experience to the edge. So AWS has partnered with a few telco providers to offer these wavelength zones, which are very closer to the telco carrier network. So developers can spin up instances in these wavelength zones and can test their applications for latency and localization. So by having multiple subnets across these wavelength zones and cloud zones, users get a unified cloud experience, both for edge applications as well as for cloud applications. Coming to GoPaddle, it's a no-code platform that helps to build both cloud and edge native applications. It helps to accelerate the time to market by a couple of features, like intelligent scaffolding that helps you to onboard applications by just reading the source code projects and building all the cloud native artifacts. and it has a few integrations with third-party tools. So developers get all these logging, monitoring, and other capabilities, CI/CD, and everything instantaneously. GoPaddle also has a marketplace with around 30 plus application templates, including EdgeX. So, by subscribing to these templates, developers get to bring up these complete stack in a few minutes. And it focuses on building a DevSecOps automation. So there is it gives all the guardrails in building applications that are highly secure right from day one. GoPaddle also offers a cloud-native governance of provisioning and managing Kubernetes environments, all from a single control plane. So you can provision Kubernetes clusters across AWS, Google, or Azure, like EKS, GK, and AKS. Or you can bring your own infrastructure and your own Kubernetes environments. So in this case, we are looking at spinning up MicroCreators-based environment through GoPaddle and centrally managing different environments through a single dashboard. So this is the overall architecture of this blueprint. So we are leveraging Terraform as the automation tooling here for the infrastructure or the Kubernetes provisioning. And while we do that, we also automatically enable a few add-ons like Prometheus and Grafana. And once we spin up multiple environments, these all can be centrally managed through GoPaddle, and developers can use GoPaddle for building their applications and deploying across these different hybrid Kubernetes environments. Okay, let's get started with the demo. I'll be uploading the blueprint template as a Terraform template into a GoPaddle console. And then using this template, I'm going to be launching two MicroCreators clusters, one in the Wavelength zone and another in the cloud zone. And then I'll be subscribing the EdgeX Foundry template from the GoPaddle marketplace. And using that template, I'll be launching EdgeX Foundry in one of these clusters. So this is my AWS console, and I have a VPC. Within this VPC, I have two subnets. As you can see, there are two subnets. One is Wavelength, another is public subnet. So now this Wavelength subnet is the one that is available in the Wavelength zone. The public subnet is in the cloud zone. And both of these subnets are in the US East 1 region. So I'll be using these two subnet IDs at the time of launching the clusters. So this is my GoPaddle console. So I'll be logging into the console. And as a first step, I'll be uploading the Terraform template. Under the infrastructure, we have an option to upload and manage the Terraform templates. So I can just give a name just to refer this template and use this name to specifically refer to these templates at the time of launching multiple clusters. So I have uploaded the template. It takes a while to complete the upload. Once it is successfully uploaded, you'll be able to see all these different types of key value pairs that are recognized within the template, its corresponding deployment architecture, and you can also see the different activities that happened at the time of upload. Let's use this template and launch the first cluster. So you can also change these files that are attached along with the template if you wish to, but I'm going to go with the defaults, and then change the certain variables like the region, the subnet ID, the VPC ID, and the corresponding key files if in case I need to log into those cluster VMs, and then I'll be launching this cluster. So let's launch this again using the wavelength zone this time. So I'll be using the corresponding instance type and the subnet ID and the VPC ID. So at the time of provisioning these clusters, the template automatically provisions the required security group. So we are looking at expanding this template to even include the provisioning of the VPC and the subnets as well. But for the time being, we expect those VPCs are already available. So now you can see that the cluster is launched. Now this is under the cloud zone, and we can see the different activities that happen at the time of Terraform apply. You can also take a look at the different add-ons that automatically got installed. And we can use the Kubernetes master IP address to connect to it. So these are the two different nodes that came up during the provisioning step. This also shows the different labels that got added. We can see that it's launched on an ARM64 based Graviton instance. We can see all the different types of images that got pulled into this node, and also the different logs logs and activities. So under the deployments, we get to see the different templates that are available in the marketplace. I'm going to be using this EdgeX Foundry template, and I'll be subscribing to this now. So once subscribed, these templates will be available under the user templates, and we can use this template to launch the application. So we have a couple of services that are already there. So I'm going to be launching this, but you can also generate a Helm chart out of this if you need. So let me launch this template on one of these clusters. So I'll have to be providing the provider type. So in this case, since it's a MicroCreator based cluster, I have to choose the cluster provider, and I'll be using the cluster provided storage. So I'm launching it with node port. So I have to give all the alternate ports for the different ports that are recognized within these services. If required, we can change the key value pairs of the environments or any other configuration, but I'm going with the defaults. Once it is launched, we can view the application. So the application is still coming up. Since it's a node port based or launch, we don't get to see any of these Nginx related metrics. So the application is still in the provisioning state, and there are no ingress rules identified. So there is one service that has come up already. So there is one replica, and you can see the containers within that replica and the corresponding logs. So these are the console related logs. We can also log into the container terminal right from the browser. See, I'm inside the container terminal now. This can be used for any debugging purposes as well. Let's go back to the application. Now it's in running state, so we can see the different services. We can choose the service and its corresponding endpoint. So I'm going to use the console endpoint. So here it has come up with the private IP, but once we have the public IP, we can actually grab it from the AWS console. Using the public IP and the endpoint, we can see that the console service has come up, and it has the list of all the other services within the application. Thank you so much for watching this video, and I would like to thank the entire Acreno community and the subcommittee in extending their help in supporting us in developing this blueprint and constantly giving us feedback in improving it. Thank you so much.